Today was a real mix. I spent time polishing up some personal projects, focusing on automation and documentation, and then jumped into LeetCode, tackling problems ranging from straightforward iteration all the way to a hard problem involving Fenwick trees. Let's see how it all went. This is day 25 of coding every day until I hit 1K subs. We've got some project updates and a few LeetCode problems on the agenda today. I updated my Python package, which helps automate typing, especially with tricky characters like emojis. The update focused on refining its hybrid approach, using fast direct typing for normal text and reliable clipboard pasting for complex characters. This involved updating the core logic and documentation, practicing skills in GUI automation and cross-platform compatibility. I also pushed updates to another utility library focused on interacting with LLMs programmatically using image recognition and automation. Alongside this, I spent time updating the READMEs for several projects, including my main GitHub profile. This focused on improving clarity, maintainability, and documentation across the board. Alongside the libraries, I worked on my DAIs and repositories. These contain scripts I use to automate parts of my content creation and progress tracking. This involved practicing Python scripting for workflow automation, touching on areas like API interaction, data processing, and general script optimization to streamline my daily routine. Alright, let's switch gears to LeetCode. First up is problem 1534, count good triplets. Spoiler alert, it's about finding triplets in an array that satisfies certain absolute difference conditions. This one's pretty straightforward. Since the constraints are small, array length up to 100, we can just use 3 nested loops. We iterate through all possible combinations of indices I, j, and k, making sure I less than j less than k. Inside the innermost loop, we check if the absolute differences between the elements at these indices meet the conditions given by a, b, and circa. If they do, we increment our counter. It's a brute force approach, running in O(n)³ time, which is perfectly fine for the given constraints. Next up, problem 2179, also called count good triplets, but this one's marked hard. Spoiler: the definition of a good triplet is different here. It involves comparing the positions of numbers in 2 different arrays, which are permutations of each other. Okay, this hard version requires a more sophisticated approach than brute force. The core idea involves using a data structure called a Fenwick tree or binary index tree, BIT. This structure is really efficient for calculating prefix sums and updating values in an array. Here's the basic class for it. The update method adds a value at a certain index, propagating the change up the tree, and the query method efficiently retrieves the sum of elements up to a given index. Both operations run in logarithmic time, which is much faster than linear time for repeated queries or updates. Here's the main part. First, we create mappings to quickly find the position of any number in nums2, and then map that nums2 position to the corresponding nums1 position for the same number. The core logic iterates through the numbers based on their appearance order in nums2, implicitly by processing values 0 to n1. For each number, we use the Fenwick tree. Query pos tells us how many numbers already processed, which appeared earlier in nums2, are located to the left of the current number in nums1. We then update the tree to mark the current number's position in nums1 as seen. Finally, we calculate how many numbers not yet processed are to the right of the current number in nums1. The number of good triplets with the current number as the middle element is the product of the left count and the right count. Summing this up gives the total. This approach cleverly counts the triplets in roughly O(n) log n time due to the Fenwick tree operations. Let's finish with an easier one. Problem 278, first bad version. Spoiler: you have versions of a product, and once one is bad, all subsequent ones are bad. You need to find the first bad one efficiently using a provided isBadVersion API call. This problem screams binary search. Since the versions have the property that once one is bad, all following ones are bad. Like a sorted sequence of good, good, bad, bad, binary search is ideal. We maintain a left and right pointer, initially 1 and n. In each step we check the middle version using isBadVersion. If the middle is bad, we know the first bad version could be the middle one or any version before it, so we move the right pointer, r to m. If the middle is good, the first bad version must be after the middle one, so we move the left pointer, l to m+1. We continue until l equals r, which pinpoints the first bad version. This is much more efficient than checking linearly, running in O log n time complexity, because we halve the search space with each API call. And that's a wrap for day 25. We covered some project maintenance and tackled a range of LeetCode problems, from simple loops to Fenwick trees and binary search. If you enjoyed the video or learned something, hitting that like button and subscribing would be awesome. Let me know in the comments if you've encountered Fenwick trees before, or have other favorite data structures. You can also support the channel over at buymeaboba.com, link in the description. Thanks for watching, and see you tomorrow.